Hi and welcome. Today we're going to perform a single-phase rotor test on an assembled three-phase squirrel cage motor to determine whether or not the rotor is in acceptable condition or whether it may have one or more open rotor bars. Before performing this test, make sure the stator winding has no grounds, shorts, or opens by performing an insulation resistance or megometer test, surge test, and lead-to-lead resistance tests. So in this video, we're going to cover how to identify the test instruments that we're going to use, correctly connect the stator for this particular test, and then to determine the single-phase voltage and current that we expect to apply to the stator. We'll measure the maximum and minimum amperage during the test, and from those two values, we'll calculate the test current variation and whether or not the rotor is good or may have open bars. We'll safely disconnect the stator leads following the test with safety first. In this case, we have a 30 horsepower motor rated 460 volts, 34.3 amps, and 60 hertz. We'll use a single-phase power supply from our test panel to conduct this test. A single-phase voltage supply usually can't supply the amperage that we need for this test. In this case, we need to use your three-phase power supply. If it's a step voltage test panel supply, we want to apply about 1/8 to 1/4 of the motor's rated voltage, and that should give us fairly close to the full load amp rating of the motor. If we have a variable voltage supply, one where we can ramp the voltage up from 0 on up to at least rated voltage, then we want to be able to provide about 3/4 to 125% of the motor's rated current. Besides a single-phase power supply, you'll need a digital voltmeter, as we have here. We'll also need a preferably digital clamp-on digital or analog amp meter. A clamp-on amp meter usually provides a more consistent, accurate reading than the amp meters in test panels today. So this gives us a little bit more ability to get the right range and measure an amperage accurately. As always, follow your company's safety practices, wear the proper personnel protective equipment, at a minimum safety glasses, and so on. All leads should have terminal lugs, and if not, we're going to want to install lugs on the motor leads and panel leads. As you can see, this motor came in with the jumpers made up and thoroughly taped, so we're okay here. We have a wire nut on the third phase lead that we're not going to be using, and we'll only be lugging and terminating 2 of the line leads from the motor to our power supply. Make sure your test panel power supply is not energized. Make sure the safety circuit breaker or the disconnect is open, and take a look at the panel meters for a little extra safety to make sure they read 0. Now we know the test panel is turned off. We'll place the motor that we're going to test near the power supply, typically on your test panel. We're going to electrically isolate one of our 3 motor leads. In this case, we have a wire nut here for safety, and then we'll securely bolt the 2 remaining power leads, so only 2 of our 3-phase power leads, to different power supply leads from the test panel. We want to be sure and separate and electrically isolate all connections from the motor frame and other motor surfaces. So we're going to attach a voltmeter to the power supply leads to verify what voltage we're applying to the motor, and we're just simply going to single phase the motor. Even if you have a metered test panel that displays the amperage on all 3 phases, many of those, they're a little bit confused by not having a reading on that third leg, because we are going to once again single phase the motor. So rather than relying on the voltmeter and amp meter panel displays, we're going to use a clamp-on amp meter so that we can measure the amperage on the 2 legs, the 2 phases that we're going to be energizing. If you're using a step voltage power supply, we want to apply about 1/8 to 1/4 of the motor's rated voltage. So we'll adjust the power supply as needed to supply the required voltage for this test. And if you're using a variable voltage power supply, we're able to raise the voltage and focus more on the current. So we want about 75% to 125% of the motor's rated current for this test. The nameplate current for this motor is 34.3 amps. So the applied power should be approximately between 26 and 43 amps. Adjust the power source to supply the required current while monitoring the amp meter. Now, manually rotate the shaft one full turn while monitoring the current with the clamp-on amp meter. Note and record the highest current and the lowest current. If the current readings vary, slowly rotate the shaft through several more rotations, noting the o'clock position of the keyway where any variation occurs. If the current fluctuates at the same keyway position each time, that strongly indicates an open rotor bar. Now, de-energize the test panel supply, making sure the circuit breaker or disconnect is open and the panel meters indicate 0 voltage. Disconnect the motor leads from the power supply, following all applicable electrical safety procedures. To evaluate the test results, first divide the maximum current by the minimum current to get the test deviation ratio. Then determine the current deviation by subtracting 1.0 from the test deviation ratio. If the current deviation is 3% or greater, the rotor probably has an open bar. For our test, dividing the maximum current of 30 amps by the minimum current of 25.7 amps results in a deviation factor of about 1.167. The current deviation is the difference between those ratios. In this case, 1.167 minus 1 equals 0.167, or nearly 17%. That's much greater than our 3% limit, so this rotor probably has an open rotor bar. If the rotor current deviation is less than 3%, the rotor is probably satisfactory. Normally when we do this test, if we have a good rotor, there will be very little, if any, current fluctuation. The single-phase rotor test is a simple but effective way to determine if the rotor of an assembled three-phase squirrel cage motor is acceptable or defective. It's also easy to perform in the service center where we have a variety of voltages available. Thanks for watching. Join us again soon for more electric motor repair tips.